gets an average and then provides the central model again to the clients for better processing. So we have collected data set from a publicly available repository which has had 82,544 bone scan images. So as you can see in the, so these are some of the samples. So these are taken from 3,247 patients gathered from West China Hospital, and there are different types of bone scan images like normal, benign, and those type of images. In our data pre-processing part, we have taken 76,050 images after excluding whole body scans, and we got 3,560 images of abnormal and 72,490 of normal plus. So as you can see in normal scenarios, we can see that the images of abnormal are less. So what we have done in this case, we have done undersampling to balance the classes, and we have then partitioned our data sets. So we have only available undersampling techniques have been used. So just briefly, what is federated learning? So this is a also known as collaborative learning or a decentralized approach to training machine learning models. So it doesn't, as I have already mentioned, that it doesn't require an exchange of data from client devices to global servers. So instead, the raw data is available on the edge device or the medical organization, and they just train the model locally, and then they pass the model parameters, and those parameters are then aggregated, and the local updates are then transferred to the global model. So in if we have used an federated averaging, and that's an extension of federated stochastic gradient descent algorithm. So in this special case, there is a clients can perform more than one local gradient descent update, and instead of sharing the gradients with the central server, the weights are trained on the local model and are shared. Finally, the server aggregates the client weights. So we have not focused much on our model because we wanted to show how the federated learning approach works. So of course, it can be these results can be reproduced with other models that are state-of-the-art models. So we just implemented our proposed model, which is a convolutional neural network, and with a 2D CNN architecture, and we trained to predict two classes. Those are normal bone scans and benign bone scans. So this is, we can see that there are several convolutional 2D architectures we have included, and max pooling layers and flattened layers. So this is our simple model. So of course, this is one of our limitations. We can probably in our future works we will incorporate more models, deep learning models. So in our experiment, we have created a global model and total client set to 4, and we have simulated the strategy for 50 rounds of epochs. And for our limitation of hardware, we set the batch size to 3, and 10 epochs are done for each round. So these are our results from the accuracy and loss curves. We will explain in the next slides more. So this is the accuracy from the global model. That is the central model that is getting from the outputs from the parameters from the individual models and then aggregated. Okay, next one. So this is the collection of all the accuracies of the individual clients and the global model. So as you can see that the accuracy is more or less good, but probably it can be increased more. So since our focus was more on the showing that we can implement federated learning, so we have not implemented other